Dear colleagues, good morning. Once again, I have to regret that we are not able to see you face to face in premises of our institute. However, I hope that sooner or later the pandemic problem will be solved and still we have an opportunity to meet in the future. I'll give you a brief introduction about our institute, who is acting as one of co-organizers of the conference. It's called Institutes for Problems in Mechanics of the Russian Academy of Sciences. In my forthcoming plenary presentation, I would say a couple of words about Russian Academy of Sciences. What does it mean? How it acts? Our institute was started in 1965, and it was founded by Professor Alexander Ishlinsky, who was a prominent and eminent scientist in the area of mechanics. And that's why once he left from us, we decided to ask and to use his name as part of the name of our institute. In general, our institute has following areas of research. It's general mechanics, navigation, dynamics of space bodies and controlled vehicles, robotics and mechatronics. In plenary speech, I will say a couple of words about robotics activities in our institute. It's also control theory, optimal and suboptimal control, fluid mechanics, aerothermodynamics, solid mechanics, mechanics of natural processes and environments. From one side, it's a variety of areas of interest, of areas of research, and on the other hand, it's very challenging because it gives us a special opportunity because people from various laboratories can interact among each other, and we may find new ideas from research in our neighborhood, and that's in advance of the whole system of Russian Academy of Sciences. Okay, once again, welcome to Moscow, and I hope to see you in person one day, and with this, I declare the CLAWAR 2020 open.
Now I'm inviting Dr. Tom Suhanov, who will tell us about technical facilities of our conference.
Greeting, dear colleagues. My name is Sukhanov Artyom, and I'm a junior researcher in the Institute for Problems in Mechanics of the Russian Academy of Sciences. And today, I will be a session chair for the first session named Climbing Robots. And for your information, if you from the technical program, the report is given 10 minutes, and the question are given for 5 minutes. Please remind this. And the first speaker is the author of an article entitled entitled "A Four-Legged Climbing Robot on a Fragile Cylinder." Oh, I'm sorry. The first speaker is Professor Ivan Ermolov with the article "Russian Robotics: State of Today, View for the Future."
Professor Ivan Ermolov is a deputy director of Ishlinsky Institute of Problems in Mechanics of the Russian Academy of Sciences. Professor Ermolov is a member of several Russian bodies of experts in robotics, and he's the scientific secretary of the Scientific Committee on Scientific Council on Robotics and Mechatronics of the Russian Academy of Sciences. He acts as a member of the Council of Strategic Planning and Prognosis of the Russian Academy of Sciences. Starting from 2018, he is a member of the working group Robotics of International Federation of Automatic Control. Has an experience in participation of several European framework program projects and of bilateral international projects. Professor Ermolov teaches as a professor of robotics of Moscow State Technological University, Stankin. His main research interests involve autonomy of robots and robotic systems, data fusion, and progressive research in robotics. And now I am inviting Professor Ermolov to deliver his plenary presentation.
Чего? Все нормально. Ну, шумит. Что ты? Солдат спецслужбы идет. Нету звука. То, что мне хорошо слышно. Dear colleagues, please excuse me, we have some minor technical problem. Так нормально слышно?
Вас слышно.
Okay, dear colleagues, excuse me, we had some minor technical problem. In my presentation, which is called Russian Robotics State of Today View for the Future, I wanted to bring to especially our foreign colleagues information about Russian robotics, what kind of research is done, what are the achievements, who are main actors in Russian robotics area, and our view for the future research in robotics. Okay, here is a brief structure for presentation. The beginning, the first Russian robot. The first Russian robot was built in 1930s. There was an attempt to create a teleoperated tank, which actually consisted of a system of two tanks. In one, the crew was sitting, and another tank was moving. The commands were transmitted either via cable or via radio signal. And actually, a series of teleoperated tanks were built, and some of them even were used in some military actions. But to tell you the truth, finally, this experience was not recognized as successful, as effective, and this program has been cancelled. Our first success came in 1970s with the two moon rovers called Lunokhod. The two rovers were launched in one in 1970 and another in 1973. Also, a crew, both of them were teleoperated, so the crew was sitting on Earth and sending signals to the rover. Then the rover was performing an action, and feedback was coming to the operators, and they were watching what was happening and creating new command. Of course, maybe from our today point of view, this was a rather primitive system. However, I want to admit that the record of the extraterrestrial trip of these Lunokhods was overcome only 40 years later, so about 5 years ago, by the now Mars rovers. In 1970s, 1980s, there was a big challenge to robotize Russian industry, and there was a special national program, and about 100,000 industrial robots were built and installed within Russian industry. However, you see a photograph of some of them, and a lot of robots were produced in Russia at that time. Most, of course, they were used in automotive industry, but also in other industries. And when I was a undergraduate student, and we used to have a traineeship in one of the factories in Moscow, we saw them working with machine tool systems. However, to tell you the truth, this experience was not also successful. Also because some of these robots were not reliable enough. Also because the philosophy of bringing robot to industry at that time, it was just replacement of human worker. However, this is not to be a correct philosophy, because bringing robot to industry is creating a new way of technology, a new industrial concept, which was not understood at that time, and the those 100,000 robots didn't show to bring big effect to national industry. Actually, a big challenge came in 1986. See, I call this slide as nothing so bad as not to be good for something. It came with Chornobyl Nuclear Power Plant catastrophe. As you know, it happened, it's a territory of modern Ukraine, but at that time, actually all Soviet Union had to deal with this catastrophe. And one of the tasks was to collect radioactive debris from the roof of the nuclear power station. And initially, some robots were built from abroad, but the level of radiation was so high that microelectronics couldn't function. And we called it that robots became crazy. They stopped being operator. And then several robots were built in Russia, and one of them you can see at that very roof. And actually it gave a new impetus for the new area of Russian robotics, which we call robotics for extreme environment. And we believe that those robots have saved life and health of hundreds and maybe of thousands of people. Later achievements, of course, the economic drastic economic transformation in 1990s had caused some decline in Russian robotics. However, some robotics still had to be surviving and acting. As you know, in 1990s, we had problems with terrorism, especially at Northern Caucasus, and this has called to life a series of reliable robots which could be disposing explosives. They called Varan and Vezdikhod, and they were designed in Bauman Institute in Moscow and produced in Kovrov electromechanical factory. About several thousands of these robots were built and still are acting in security offices all over Russian territory. Another stream for nuclear plants was generated in 2010s when Southern Federal University, together with Russian Atomic Agency, have created a robot for manipulation with fuel elements at nuclear power stations. As you know, actually, that fuel elements have to be removed from time to time. Usually it's once a year. They have to be removed within the reactor. And during this removal, a reactor is not functioning, so power station is not producing electricity, which is a loss of efficiency. And a team of these prominent people have created a robot to move, to make this manipulation with fuel elements. And besides manipulation of cells, there was done a big deal of trajectory optimization, of the control of the functionality of fuel elements, and through building, through introducing, I think 6 or 7 of these robots within Russia, we got about more than 300 millions of dollars additional income to atomic energy each year, because the time of service time was decreased. And some of these robots were also installed abroad outside of Russia. Another interesting company producing robot for municipal services called TARIS. You can see one of them on this picture. Have produced a series of robotic crawlers for pipes of different diameter and of different functionality. And it could not only inspect the pipes, but it also could make simple repair works within the pipe. And also some of these robots were first produced all around Russian municipal services, and some were exported to other countries. In 2000s, a new industrial robotic program was started by LADA Car Manufacturing, because automotive industry was still the main consumer of industrial robots. And a special department of this car manufacturing company has created 4 totally new types of industrial robots, and they were produced and installed within the premises of these of the factories of LADA car manufacturers. Now let's speak briefly about main players. Of course, I would not be able to name you all the robotic laboratories and companies within Russia. It would take not enough time. It would take a lot of time. However, I wanted to give you an overview, and I also hope that with this you may find some possible partnership links for your future research. Now, as I promised you, a couple of words about Russian Academy of Sciences. In 3 years from now, it will celebrate 300 years. It was started by our Tsar Peter I. And actually now, Academy of Sciences unites about 400 research institutes. And what is the most interesting, that they come from various research aspects. It's from humanitarian, from medicine, from agriculture, from mathematics, physics, mechanics, informatics, biology, and so on. So this gives us, as I said before, a special opportunity for cross-fertilization and for getting new ideas, because we intensively communicate with each other. In our Academy of Sciences, we do not have a special separate institute for research in robotics, but these activities are coordinated by Scientific Council for Robotics and Mechatronics of Russian Academy of Sciences. And as you know, it also participating, it has participating in organizing, in helping to organize this conference. And this council unites about 50 specialists in robotics from all over Russia. And what is important, not only from academia, but also from industry, from university, from decision-making governmental bodies. So it's a very good place to meet and to discuss the needs, the possibilities, the opportunities in our robotics research. Now, let me start first with Ishlinsky Institute for Problems in Mechanics. Of course, more details will be given by my colleagues within their regular presentations, but as you know, its key topic is climbing robot, capsular robots. Now also we move to new locomotion systems, exoskeletons, manipulative robots, and so on. Our, I call it a brother institute, is Institute of Control Sciences of Russian Academy of Sciences. They have some good achievements in high precision navigation of robots. You know, it's especially important for like robots in agriculture when you need precision better than decimeters. Also has good results in aerial vehicles, unmanned aerial vehicles control, collaborative robotics, and a new areas they have started cybersecurity in robotic systems. Another institute is called Keldysh Institute of Applied Mathematics of Russian Academy of Sciences. They make research in machine vision, also exoskeletons, especially with application to the medicine. And they have a special program for unmanned vehicles. You can see it on one of the videos, photographs below, and research in the area of sensor fusion. Now continuing with Russian Academy of Sciences, but if we move outside of Moscow, it's of course St. Petersburg Institute of Informatics and Automation of Russian Academy of Sciences. You see they have a very active team in the area of multi-agent control, and they participate in a lot of international competitions in this area, like in robotics, football. It's also cyber physical systems interaction and control of Android type of robots. On the another photo below, you can see there was a special research done in the manipulative robot for the space program. Now, Mechanical Engineering Research Institute of Russian Academy of Sciences, it's back in Moscow. It has a special program for their very good specialists in manipulators with a closed kinematic loop. Actually, they have done a big research on different types of closed kinematic loops manipulators and have studied the efficiency of various schemes and produced recommendations which could be very useful for building new robots. And also they have some good advanced, I would say, results for bringing industrial robots for completing contact technological operation, like for polishing turbine blades. You can see it on the photograph below, and some of their robots are installed in the aviation turbines factory in Moscow. Now, if we move to the Far East, we have there an Institute of Marine Technology Problems, and an interesting fact that actually within maybe 20 or 30 years, this was the only body in Russia who was actually producing robots, submersible robots in Russia. So no company was producing, only this academic institute was producing underwater robotic systems. And of course now we have joined, they are joined by big maritime technology companies, and now this institute can specialize now in submersible robots control and modeling, where they're very good experts. If we move to the Urals, we have an Institute of Mechanics of Ufa Federal Center of Russian Academy of Sciences. They work in the area of multi-agent control, and they try to create, you can see it on the photos below, manipulators with new mechanical effects, like a snake type of robots with a very high maneuverability. Now we speak about other universities and research institutes outside of Russian Academy of Sciences. In St. Petersburg, we have a big research body which is called Russian Center for Robotics and Technical Cybernetics. Actually, this center initially was started as a center for design and building robots for Russian national space program. And they are very good specialists in space robotics. I know they have some good collaboration links worldwide, but also they produce lightweight unmanned ground vehicles and have a strong position in machine vision. Back in Moscow, Bauman Moscow State Technical University. This university, I would say, is the chief research bodies among universities in area of robotics, because they have a large variety of robotic research spectrum field. It's both industrial robotics, unmanned ground vehicle, unmanned submersible vehicle, medical robots, and now, as far as I know, they create a totally brand new center for robotics and automation, which I hope next year will be started, which will unite under one roof these about almost dozen of robotic departments within one university. Another university is called MIRA, Russian Technological University. Robotic team of this university has a prominent skills in intelligent control algorithm in robotics, and lately they have started a new wave of industrial robotics research. And actually, those of you who have followed the program of our conference, you know that initially, in case our conference will be really not virtually held in Moscow, we were planning a visit to the Industrial Robotics Center in this university, which is called Industry 4.0 Digital Robotic Production. Still, you can see some photographs below. And what is for me was very challenging within this center, that at one place in one closed system, virtually closed system, they were able to present the collaboration of several generations of robots, starting robots working, which were built in 1980s, 1990s, and up to top modern robotic systems. And those of them were acting in one big system. Moscow Technological University Stankin, which actually is my alma mater, and I have graduated from there. And it is specialized in industrial robotics. Lately, it has its own program in mobile robots, and now the last 4 years, it has a new challenging program in medical robots. You can see some photos below, and I know a good side that they making this program together with one of the medical universities in Moscow, so they have some very good advantage in research in this area. Southern Federal University, actually it's a big university which unites a lot of research institutes, and one of them has a long-term history of multi-agent control of robots, and actually consider that it is a chief research body in the area of multi-agent control for robots. And also it has some good results in control algorithms. And as you see on another photo below, they have very good results, and also they have introduced it to several industrial points, the palletizing robot systems. Back to St. Petersburg State University of Aerospace Instrumentation with the Mechatronics drive and multi-agent control. If we go to the Volga River, Kazan Federal University, they have a very strong team in the area of intelligent control algorithms, and I believe there are several presentations of them now within our conference. And NASA, they also start a new program in industrial robotics because they have a strong industrial sector in the area of Kazan, especially the aircraft building sector, and also the medical robots program. Now, our colleagues from the famous city of Stalingrad, or it's called now at this moment Volgograd, Volgograd State Technical University. I know they have a lot of presentations within our conference, and actually the key topic is walking robots. You see one of them on the top photo, and now they bring their robots also under the sea. And I hope they will present some of the robots within the programs of our conference. And those robots are very effective in agriculture, in emergence system. Now, if we come to emergence system, we have a special research institute for fire protection, which is outside of university of academic sector, let's say. It's part of Russian Emercom, and within this research institute for fire protection, they have constructed and produced a series of robots for firefighting. As you know, our country have a lot of forests, and as soon as country in some places is underpopulated, we have a problem of fighting these fires, especially deep in Siberia. So because of this, some good results were produced by this research institute. You see some of the robots, and also I know that some of them were actually used for firefighting. And some of the robots are produced for infrastructure maintenance, which is a key topic for a lot of robotics around the globe now. And also very good colleagues of mine, which is who are called now Dukhov Automatics Research Institute. It's part of Russian Atomic Agency. And as I said, after the Chornobyl nuclear power plant catastrophe, there is a demand that each Russian nuclear power station must have a rescue robots on its territory in case of some emergency situation. So this company, Dukhov Automatics Research Institute, is responsible for building these robots for training operators, and in case of need, bringing more of these robots to the place of emergency, and they are very have some very good results in this area. As I have said before, there are more places on Russian territory and more universities, like lately we have so-called Skolkovo University, or special university in Innopolis, Sevastopol in Russian Crimea, Kaliningrad, North Arctic University, Omsk deep in Siberia, Tomsk, which has actually several universities specialized in robotics. And I advise you, in case you are interested, you can either contact those colleagues directly, or you may contact me, and I would help you to build possible collaborative links with those people. Now, speaking about our view for the future, actually, I hesitated, but finally I decided to bring you this slide, which is called Why Robotics in Russia. First, its industrial potential. As you know, Russia now tries to revive its industry, which has suffered big breakdown in 1990s. So there is a lot of work for Russian robotics. We have huge underpopulated spaces, and a lot of them have really hard climate, and still people who live in those spaces, they should have modern services at high levels. So it's a big niche for robots to help those people, to service the people who are living there. By the way, a lot of people speaking about Russian dimensions, they never think that about 40% of Russian territory are actually situated at the place we call it eternal free space, which most of the time have the climate temperature of the soil below zero. And finally, two ideas came to my mind that actually Russians have a, let's call it reckless, risky character. This term came from one of my German friends who said, you know, if you need to invent something like to send it to the moon or to the space, something risky, you should call Russians. That's in their character. They like to do risky things. And finally, we have also, as other nations, talented people, and we believe that we have a good word in robotics future. Now, if to be more serious, what do we have as a future development in robotics? We foresee the 5 main dimensions. It's a search for new applications in robots, because still we consider that there are more possible areas for robots to be used in industry, in human society, in research, and so on. Still, all of us who are professionals in robotics, we admit that in a lot of cases, we must admit that we are not satisfied with the level of performance of modern robots, so we should increase the efficiency of modern robots. Of course, we should move to application of robots in groups, and this calls a new challenge to make modern robotic systems as to make them more autonomous. However, autonomy is a good thing, and I'm in favor of it, but still also we admit that majority of modern robots, especially in some important applications, still are controlled by human, and that's why the human-robotic interaction, human-robotic interface is another aspect which we should further work on, especially considering the ethic aspect that some robotic applications like robotics for security, a human will always have a final word to make his or her decision to for the robot to act. Outcome of this, we see this following emerging directions of research, that is modeling and simulation, new control method and strategies, artificial intelligence, group application, and biomedical aspects. Speaking of modeling and simulation, we think that we should produce more advanced modeling of various robots, and especially for robots acting in severe or difficult environment. We should create new application scenarios and model those scenarios and simulate them. Actually, from my point of view, in our future, every company producing robots and selling to the end user should sell not only the robot itself, but also a ready-to-use model or simulative software, so that before using a robot, end user could check if he really needs it, how he or she would use it. And also a model and a simulation of group of robots. Now, new control methods and strategies. A big challenge of my point of view, if you look to the scheme on your right, you see the one produced by us, hierarchical scheme of control levels, and we try to separate various control tasks performed by a robot into 5 areas. You know, there are various what is called architectures. We have produced this one because we consider it's more intuitively easily understood by end user. And sometimes within the conference, and I believe also within this conference, we would have a discussion which method is better or worse to solve this or that task within the robot. From my point of view, we would never have a universally perfect controlled methods which would be able to solve all control tasks for the robot. And I believe that for various control levels, for various level of hierarchy, we would have this or that most effective control methods to implement this task. And for example, for parameters identification of a control in one drive, we know like PID. If we go further up, we would have fuzzy logic, neural networks, if object recognition. Later we have deep learning algorithms. But if we go up and up and up, I believe we still have to search with which method are the most effective. Returning to control tasks, is controlling robot in emerging environment, especially in fast, drastically changing environment, optimal and suboptimal control and artificial intelligence algorithms. Now, for group application, it's methods of controlling robots in various groups for various application. A big deal we have to solve the problem of communication of robots within their groups. And finally, we should always keep in mind that despite unmanned system on our roads, which are appearing and would appear in more quantity soon, still a lot of systems would be human-driven. And the question of integration of robots with these human-driven machines is still should be kept in mind. We should keep them in mind and produce new scientific methodology, new technology to incorporate such systems into one effective system. And now, speaking of biomedical aspects, we consider we should study more the human robotics interfaces improvement, including multimodal interfaces, its exoskeletons, its psychological aspects of robotics. Actually, in December, last December, our Scientific Council of Robotics of Russian Academy of Sciences, we have a special session in this topic where we have invited people both from robotics and people from psychology, and we have communicated and discussed this aspect, and it created quite created a vision that there exists quite several very serious challenges to be solved. Now, from my point of view, yes, of course, robots in medicine, and a very big challenge for me is to create an effective system for robots to evacuate injured people by robots. Now, I have brought you up the key players in robotics, our view for the future robotics research, and now just very briefly possible collaborative links, because as we know that every collaboration besides will of the people to collaborate, unfortunately, well, always brought down by the financial factors, and these collaborations should be supported financially. Here I brought you three possible sources. One of Ministry of Science and Higher Education of Russian Federation, which from time to time launches a special program for international scientists to come to Russia to make research, to bring, to build joint laboratories. Another very productive institute is called Russian Fund of Basic Research, who actually, as you know, have co-sponsored our conference. And I bring you attention that this fund have a lot of bilateral agreements with your national bodies. So you may consult your national Ministry of Education or of Science. And I know that such sometimes such agreements are done not with your national ministry, but with some national body, like with UK, such agreement comes with Royal Society. With Germany, it comes with DFG, and so on. However, there are some grants launched every year, not very large, but very sufficient to support such possible collaboration. So I advise you to check the website of Russian Fund of Basic Research and also your national research supporting body for such programs. And finally, it's Russian Science Foundation. Also, you may find its website and find information for possible collaborative support. And maybe some more which I didn't bring here because they may not be on a regular basis, but still it's you may search for some more support, including, I would say, European Framework Program. Also, Russian partners can participate. It's a bit, it needs a bit bureaucratic work, but still we have participated in such projects, and we consider it to be productive for both European side and Russian side. So also there is this opportunity and acknowledgement for the presentation of this information to you. And my basic conclusion that Russian robotics has a long-term history, I would say rather impressive area present, especially in some areas like in robot supporting nuclear industry, and it has a challenging future because there are a lot of tasks which have to be solved in our future, and I believe that those of you who are interested could be part of this future. Thank you very much. Thank you. Please excuse me again for that technical malfunction at the beginning. If you have any questions, I'm ready to try to answer.
Thank you, Professor Ermolov. Please let me tell a few words to our participants during the presentation. While the presentation, please mute your microphones to prevent noise from outside. And, if you have some questions for Professor Ermolov, you may please introduce yourself and ask your question.
Okay, colleagues, if there are no questions, the email is below, and you can find more information in our website. And please contact me. I would be glad. You see, the idea of our council is not only to bring cooperation for ourselves, but to our other colleagues in Russia. So please contact us. Thank you. Thank you, Mr. Chairman.
Dear colleagues, our first plenary session is over, and at 10:30 UTC, we will start our regular session on climbing robots. And please be prepared for your presentation. And we have about 20 minutes break, and at 10:30 we are waiting you at our regular session. Thank you.